Welcome back, everybody. It's your boy Mocha Engineering. We're gonna be doing the motion system upgrade on my Daedalus here. It's gonna be my favorite part, and I think everybody's favorite part. But we are gonna start off by upgrading the linear rails, cleaning them up, all the X, Y, and Z linear rails. And then we're also gonna upgrade the bed along with the rear motors that are attached back here. They all need to be cleaned up and upgraded and really just touched up. This thing hasn't been moved in about, I don't know, 20 years. You can see all this dust in my hand here. We're gonna also touch up these linear rods, these threaded rods for the bed. They also considered the motion system. And I'm gonna show you how I'm gonna detach the DC bed and change it into an AC bed so that we can use mains wiring and we can bring this thing into the future. But yeah, let's start off with the motors and let's see where this goes. All right, in my hands, I have the current motor stack that was from the Daedalus. This thing looks pretty great. It's really nice. It looks honestly pretty great. And we are going to take this apart. And you can see here, I wanted to show you guys what the motors were. These were 1684 MAC motors, which they're not bad, but I want to bring this into the future. Here are if this focuses, the 2504 motors from LDO. Super strong, super great motors, way higher torque, and much better about handling the torque outputs. We're also going to be adding a dampening system that I found on AliExpress here, and this is going to be a bit of a challenge since there isn't any guides on how to build it, but I'm really excited to show how I find building it and incorporating all of this into the motor system that we have currently. So yeah, there are these top stabilizers here that we're also going to include, along with a coupler and a shaft. Here is something I just noticed as I'm building this. As you can see, what you'll want to do here is you'll want to get rid of the two back screws for anybody that's also following me here. And as I was removing them, they're pretty crusty. Look at these screws with all that Loctite. It has been about 4 or 5 years. But it looks like these screws you can't really get out from the bottom. They will actually interfere with the idlers. So what I thought about is just cracking them loose, pushing it back so that you can actually fully back out the screws and get the motor out. So I don't know if there's a full assembly of how to put this thing together, so I wanted to show you guys this before we started. But I took some IPA, cleaned up the entire motor stack. It was pretty greasy from some residue. It must be like leftover oil from the idlers, plus the belt grease and grime, and a ton of other crap. So I cleaned that all off, cleaned the motors off. But here is the way that we're going to assemble this roughly. So first things first, we're going to put the idler on, not the idler, the actual dampener onto the motor. And I'm going to show you guys in just a second. There are two sides to the dampener, so you'll want to line this up. And there is a through hole side on the dampener here, and you'll want that one facing the bottom. And then there's a threaded side on the top, and you'll want that facing upwards. Through hole so that we can put a bolt straight into the motor, since the motor is threaded, so we don't need to do a double thread. And we'll want a low profile bolt, something like a button head screw, to install this, just so that it clears the other add-on that we're gonna put the top part of the dampener here. So be sure to add that on, and then you can slide this item in as well. But before that, we will need to add the coupler. So when you put the coupler in, try to slide them on, and you'll want the grub screws to land on the flat D shaft part of the shafts. But yeah, we'll want to put this in before we put in the top part here. So after you've put on the actual dampener, we'll need to put this shaft and extension and coupler. And what I really wanted to show you guys is you want to kind of put it right in the middle. And if you can see I'll zoom in. If you can see right in the middle here, you'll want to get the stepper motor shaft to be right in between the 3 cuts of this coupler. And you can see it right here when that shadow appears. You'll want to stop there, and you will want to tighten up the coupler, and then afterwards, make sure that you install the shaft, and the shaft should be about halfway into the coupler as well. Also, the biggest thing to remember with these couplers is to always take out the grub screws, and every single one of them, take them out and add a ton of Loctite. You don't want to forget about this part, because these grub screws can come back to haunt you if any of them become loose. And there are two sections to this grub screw. There's a side on for the D shaft side, and then there's a second one nearby for you to also, I'm going to rotate it around. Here is the second grub screws, and they're right next to each other. So you'll want one side on the flat of the shafts, and then the other sides you'll want to also make sure you torque down. So yeah. And we will need to make sure that we have a shorter bolt here. I used an M3x8 on both sides so that it is just long enough to penetrate through the through hole and into the threads, and also be able to attach there. And then we'll need some more M3x8s to attach to the top. Here we have it, the entire assembled stack. I think this looks really nice. Honestly, it came out really well. And one thing I wasn't really sure about was aligning the idlers, and it actually turned out really easy. It was pretty much super simple. You just, align it by eye. The bottom ones, align with the bottom ones up here, and then the top ones on the left. I'm gonna try to zoom in and focus. But yeah, the top ones on the left, we just align by eye, make sure they fit. I also decided to put a piece of the belt and make sure that worked as well. One thing I did notice is that there is no space or no place to put these top stabilizers for the couplers. Ideally, you would want some type of spacer that works on this bottom two screws, the diagonal screws, and that does not work. You got to imagine there is going to be a belt that goes through this entire thing. So we're going to have to come up with a creative idea on how to incorporate these bearings and ensure that they hold the shaft rigidly. So I wanted to show here, if you were to put spacers, it would actually interfere with the belt path. I think they could barely fit, but they would interfere with the belt path, either with the top or the bottom belt. So it's just a misfortunate thing. Obviously, these were designed for the Vorons, and I'll show you guys in just a second on the catalog. And here is the actual dampeners that I used. These are pretty nice dampeners, and they are currently on sale. I bought them on their high, which really sucked, but they're about $25 now. You'll need 2 of them. And here's the whole assembly. And as I was saying, this is definitely used on like a Trident build. I think if you were to try to use this on a 2.4, it would not fit. So yeah, this is for a Trident sort of system. And if you have such a system, I would highly recommend you get them. The only big thing or big downside to all of this is that there are no fasteners included and no instructions. You kind of just need to put it together. And if you have a mechanical sense of assembly, it's really not that hard. So yeah, just wanted to show you guys that. But yeah, they definitely do not fit for the deadlifts. If I could redesign it, I would redesign a new plate, and the new plate would 110% incorporate this. But this is not the case right here. So yeah, we are going to have to come up with a new plate design, something that kind of fits underneath one of the 2020 rails and can hold these 2 bearings on top rigidly. So this will be a fun little side quest, and yeah, let's get this done. All right, so where we left off last is that we needed to create some sort of way to hold these stabilizer bearings at the very top of our system. Now, I had to come up with some funny way to kind of hold it stiffly under one of the 2020 bars. And here is my solution. So this is a really overbuilt, pretty beefy way to hold this item. And we've got the 2 bearings right here, securely mounted. And the way that this is going to work is that if you could imagine, this is where the 2020 rail is going to be and where it mounts. And it's going to mount upwards with these counterboard screws. We're going to be using really long bolts. I've got some M3x30 bolts. And it's going to mount upwards. And then from the front, as you can see, these bearings will perfectly align with the actual motor right there. And it's not level because there's a motor shafts, you know, the actual motors aren't level. So it's not going to be level in this case, but in the actual printer, it's going to be level. And yeah, as you can see, that works. It turns beautifully. I think I added some, yeah, there we go. Added a Sharpie marker so that you can see actually rotate. And you guys can't tell, but I can tell. The motor moves very freely, and you can feel that it's super supported. But yeah, this worked out better than I thought. And I'm actually going to show you a little clip here of something that I ran into that I was completely not expecting with this whole build. I thought the whole printer was going to be a lot easier to take apart, but it wasn't. All right, one of the things that you will notice is there are blind joints just like this holding in the frame. And I think Project R3D used like red Loctite to get these things out, and or to put these things on, and it was horrendous. Like, it is almost impossible to get these things out. I had to ghetto rig some pipe clamps onto a 3mm bolt, and there was a circular section. Come on, focus. There's a circular section on my pipe wrench, and I had to torque these things out the correct direction, and it literally smelled like gunpowder as it was releasing. So that is a big thing to know about this when it comes to this frame. Yeah, so I'm glad you guys got to see that annoying part, but this part works and it came out perfectly. So I decided to print it out in a much nicer filament. This is CF carbon fiber ASA, and you can see the two lines that kind of ruined the side view, and this is because I had two cases where the filament tangled, and I needed to reinstall some filament. We are now going to get this installed on the deadlist, and I will show you just a little bit about that. So here's what the back of the deadlist looks like right now, and that means that I need to take out this duet board so that it can actually mount nicely. And as you can tell, I also did move this bar down after the hell that was, so I'm going to keep that part down, and we are going to go through, take this part out, and then install the actual motors and see how that goes. All right, so we are actually going to do the install of this entire system in here. One thing you're going to need is you're going to need your motor plates. So this is the entire, you know, motor assembly that we just finished up here. And now we're going to install this right on the top right here. And what I recommend is yeah, get this this bar loose, and you'll take your 3 screws, move them. You know, these are going to be M5 screws. Get them roughly in the right place. And one thing you'll need is you'll need to align these in a way that's pretty nifty here. It's going to be a little bit annoying to know how far these bolts need to be apart. So what I recommend is that before you put it on, kind of space them out correctly like this, so that when you go around to actually installing them, they'll be perfectly in line. So that'll be a little top tip. And the other screws, you can't really see them, but they are, let me see if I can find them for you. There are 3 set screws up here as well, and you'll take these 3, and move them up over here so that they correctly align with the little top tower thing we're going to install. But first ups first, we're going to install the motor mount first, and then we're going to install the actual stiff bearing tower up here, and then afterwards we're going to kind of slide this bottom tower into place and then lock it in. Not sure if I showed this in the last clip, but since these parts are going to be dealing with a lot of vibration, even with the dampener, I highly recommend you use some Loctite. And I have my little Loctite in this blue little cap, so if you see this around, it's just Loctite. And I highly recommend you put this on every single bolt that you will be installing on a 3D printer. Just because the bottle is red does not mean it's red Loctite. I recommend only blue Loctite. Don't use anything stronger or anything weaker. Not sure if I showed this part earlier, but here is just me with this rigid plate for the bearings. I'm going to also include a link to this on printables in the description below. But I wanted to show you guys just me installing the bearings. So there is a counter bore pretty much all the way down here, which is going to be a little bit hard to see, but you'll see it in the model. There's a counter bore, and all you'll want to do is take the bearings, and you can easily just take it, press it all the way down by hand, and you'll feel a very snug but good fit. And once it reaches the bottom, it'll bottom out, and you'll know you're good. So you'll want to do that with the second bearing. Take that by hand and press it all the way in, and it's a nice snug fit. Like, it's not going to be enough to fully seal this in forever and ever, which is not my point, but it will be able to be easily installed. So yeah, there's that. So belt path stuff, and this looks really rough right now, but what I'm trying to do here is this lower section is going to go with this lower section on the motor mounts. This top section is going to go with the top section of idlers here. The reason why I'm trying to get them roughly in the right spot, not exactly where I want them, for two reasons. One, these bolts are going to be really hard to navigate once we put our top piece on, so we want to get them in the right spot roughly. Two, the way that I know that this is the correct path is I took a photo beforehand of what the entire path looked like, and I remember this sort of length. The other reason, the last one, is that based on the way that our electronics will lay out in the next episode, I want to still be able to move this thing around so that I'm not fully locked in. If I find something doesn't work, if I find something I don't like, we can have this in this area while also not kind of running into a lot of other issues. So yeah, let's continue on with the build. Okay, I wanted to show you guys a little progress update of what I've been doing. So I finally got the top part here installed, and this is kind of how I've been aligning it, since there's no real way. What you'll do is you'll just take this top bar, and you'll just slowly start guiding it until you see these two posts hit the inside of these two bearings, and you'll take some adjustment, but once you've got it in just like this, that's a pretty good fit. You know, it looks like it's good. You can take your hand and go underneath and just spin the bearing, make sure that it spins freely, and then you can very carefully with a bent wrench, with a little Allen key wrench like this, you have just enough space to fit it, go into the counter bore, and turn your key. So yeah, here we go. Here's a little close-up view of what I'm dealing with. As you can see, these belts would have really sucked. All right, so we've got this thing finally installed now. It was a pretty nice install, you know, everything went pretty well. So I installed the bottom plate, installed the top plate separately. I went into the CAD and figured out this distance. It turned out to be about 56.5 millimeters from the edge. So I decided to use that. And what I did afterwards is that I took this bottom panel, and after it was down here, you know, I kind of pushed it into place and aligned it with this top plate, and it went on pretty well. One thing you will notice is that when you do that, there is a chance that the bearings here pop out. So you'll want to make sure that these bearings are actually seated all the way down and that they actually work the way that they are intending. All right, so I did end up wanting to tighten this down because it was slopping around and I didn't really want this all to fall down and break. And to ensure that the height didn't get messed up, let me focus. To ensure that the height never got messed up from the original, I took a measurement and then 3D printed out these blocks so that I knew the height that it needed to be. And I knew that these blocks needed just to slide in really easily, and like they are right now. I'll make sure to upload these blocks if you guys want. And what I did is that as I'm tightening these, tightening this bottom part here, I just pushed it up against these blocks and then use these 2 bolts here to tighten it up. Also, you want this beam here to be super flat. So if you have a piece of metal somewhere, I would push it up against this piece and then tighten the sides and then feel it with your finger, and there should be no noticeable ridge there. So yeah. The tinkering never stops, does it? So what actually ended up happening at the very end of this video, I was moving the belt, the tool head around, trying to see if it felt as smooth as it did when I first started. And I noticed that there was some roughness in the whole system. So I didn't really like how that was. I noticed that the belts were sitting a little bit too low. So the belts would kind of like, instead of going straight through the idler, through the motor and out, it would kind of move down towards the idler and then back up towards the pulley and then back out towards the rest of the system. So I assumed after looking at it that my system here just wasn't allowing for any sort of motion or play on the actual motor shaft. And I actually ended up looking at it much closer, and the pulley that sits on the motor was rubbing up along this up along this bottom surface here. And I don't know if you can see the wear marks. Yeah, right there. There should be a circular wear mark that should kind of show, but I noticed that this part did not really work for that. And so, of course, I redesigned the part, and I actually, you can see the differences here. I actually didn't like having to mount this on the top of the bar because it kind of, well, it added 3 screws, and I wasn't a big fan of that. So what this mount will do is that it will use the 3 screws that already come with the motor brackets, and we just cut them down deeper. It's a deeper counter bore so that it can reach all the way down. So we're using M30 bolts. They're going all the way down into the parts. And what this part is different is that now I've added quite a large counter bore for the idler pulley, so that if the idler pulley ever needs to come up here, it has a shallow edge where it can go up to allow the belts to be straight. And I added little viewports right here so that you can see the belt path as you need. It's installed here in PLA, and I like this a lot easier. It's a lot better. You just use the bolts here, here, and here, and it mounts already here. I saved 3 more M3 or M5 nuts. And the biggest thing is that pulleys are viewable. There we go. Here you can finally see the pulleys, and the belts are straight. Now I haven't moved this bar up yet till it's totally good, but when I did, it allows me to fully move it up and down as much as I need to, and I still have access to the pulleys here so that I'm able to get it. So yeah, I reprinted it in the CF-ASA, and I'm going to install this now, and then you will see it in the electronics episode. So yeah, this was a much better upgrade in my opinion. Much sleeker, much nicer. It doesn't interfere with anything, and you can get the same rigid effect for these 2 bearings. So I'm very happy with this design change.